I'm going to try my transfusor again. I've put 3 extra pumps in the vacuum pump, three more stages. And I think I've looked at the vacuum I was getting, and I think it's 20 torque, which is it's not that low, but it's 20 torque, so it's all I can get. The 3 extra changes made a very small difference in what I can get, about 10 torque. First 20, so that's actually not very much. And then that's much smaller than the other pumps. They're not the same weight. Very good. And so I'll do that. And I'm using the probe that measures the electromagnetic pulse is actually in a coil, separate coil, away from the actual unit, and it should pick up a spike. And I haven't tried it yet, so I'm going to how big the spike is. And that's for the trigger pulse. But so I won't be putting it on the coil itself because I don't have a high voltage probe. And there's all sorts of problems caused by that probe. And so I'm using it. I haven't got a high voltage probe, but it makes it stuff. No, I'll be buying one. I don't have any money. And so that's what I'm doing. So I'm now going to get the probe over here, which is, I'll get a shock of this thing if I'm not careful, because it's very close to the high voltage line. So it's a high voltage line from the other side. But simple as that. I didn't do that very well. And it's primed, it's armed, so it comes up here. Hangs over. So now I'm going to switch over to the camera and see if I can see a pulse. So I'm going to see something. Let's see. Oh yeah. Switch over the other. Switch over. So you can see the transfusor in the corner there. Okay, so let's just go back to the apps displayed. I've got some, so channel 2 has got a rise to a frequency, but it hasn't recorded the voltage. I'm not sure. And it triggered that thing out. Okay, that's no good. That's no good at all. So that's right. So just release that. I have to, it's actually such a powerful trigger actually. Yes, sir. It doesn't actually do anything. I'll get you with the upper trace is the neutral detector. Two, trigger, three, single. So it's actually, well, it's got pulses on it, so it's actually two. So actually, I see nothing there. Seriously. Actually, I heard that through that pulse rate. Pulse rate. Hey, crashed the screen. The screen is red when that happened. So it's not very good. So it's actually putting a pulse on the oscilloscope, which it shouldn't do. So it's pretty strong in us. So I'll move that coil away. Let's just put it on back on the mouse is gone. Mouse has disappeared. Mouse has crashed. All sorts of things are on. Just reset it out. these high voltages don't mix with that. Computers, you know, it must be an electromagnetic pulse, which I can't see. So, the mouse isn't working now. This is installing device driver software. It's actually crashed it. That's not very good, is it? Not very good. So I think what's going on. This will take that coil away. Take the coil away from here. Take the coil away from there. So let's move the coil away. Let's store this on. So the mouse fails, it's no use, is it? So the way the mouse has failed. Why should the mouse fail? It must be a high voltage one. So I have to stop it. I have to close down. So do it slowly. The transfusor, when I triggered it, it crashed the computer. The screen went blank, and one of the ports on the hub, the mini hub, was broken, so I can't use it, which is useless. So I lost the mouse. The mouse failed, so I plugged the mouse into another port, but I couldn't use that port. So I've got to replace the hub. Hopefully the other ports work. I haven't actually tested them. I think it does. Do that later. So I may have broken the hub altogether. So that's probably the electromagnetic pulse. I don't think I had it pumped down then. When I pumped it down, there was immediately noise, spikes of something. And I think the transfuser was about to start up. I think this was the part of the pulses were quite big. And it wasn't noise from the pumps, because without it pumped down, you don't get, if you go for the valve so the air goes straight through, that doesn't happen. So when you close the valve, the pressure drops out, that starts happening. So it's not the pumps, it's something in the transfuser itself. So if I get the pressure light, I would probably start up straight away, or if I use deuterium. It's down the three extra pumps I put in, which are not the right ones, they don't match, brought the pressure down to 20 torr. I read it probably 20 torr. Before it was 30, it was 30 or 40 torr, so it's not enough. And 20 torr, and it really should go down lower than that. It should go down to 5 torr. Now I can't do that with my system. The three extra pumps didn't make much difference. I need to get different pumps. I think they were cheap ones from another company, and they're not so much smaller capacity than the ones for smaller flow. And probably the same pressure but a smaller flow, so they can't match up with the other ones. And I need to get. I can't get the other ones. The person who originally provided them said the supply dried up. But I might ask him, write to him, and ask him if he could give me the name of the supply so I can get it directly. They're not that expensive, so quite useful. And so I think this supply. I think his name was Think It, Make It, I think. So he seems to have some ideas. He was just useful things, and he'd be pleased to know I used it. I did always noises on, but it's not me. There's not noise on that recording. I can't hear it. It's I can see the fire thing flashing up and down, but I can't hear the noise. So I really that's not recorded. And it's actually quite a good system. It does seem to work, and the pulses I did a pulse train, and they were about 2 microseconds apart. So I don't know what they were because the oscillator just the actual coil resonates at around what should I say, 700 hertz. So I measured it. So that's not running at the. It's probably multiple breakdowns. So it's a multiple pulse. So I know what it's doing. So I think I'll probably need a smaller number of turns to get the coil to resonate at about the same frequency as those pulses. So that's about 5,000 hertz. Well, that's so if I have a, I think if I make another one, it'll be a 20,000 turn coil. I think I'll be more reasonable up there. So I think you're thinking of making one from this thing here. So these go like that, and the tube get a plastic tube inside. You can get the right size. When they glue them in, very small, like that, and that they put a glass tube through there. We can't get a glass through it directly. Of course, widen it straight onto the glass tube. That would be a problem. So you can't change the glass tube. Cheaper construction, which you can't change it. And but it doesn't use it up because it's the gas is replaceable. If you want to put a tube in there, an engine tube, you have to replace it, and that's another possibility. So I might do that. Those sorts of things I might do. I consider before I do things. I experiment in my mind and do diagrams and things, talk to people, but not very much because people I normally talk. Well, the person I had friendship with has been. What's happened to him? But he's been taken out by a psychiatrist. I spoke to my caretaker to carry. He wants to get rid of me. So I wants to get rid of me. I'm not sure who it is, but I think they're not so worried about me now because I'm trying to worry about some things. But he came round today. This morning, and I asked him about this man. I called him Brian. It's not his name. But he's telling man, he's disappeared, and I'm trying to get through to him. Now, he told me some time ago that he'd been put on olanzapine, last dose of olanzapine, because to get hallucinations of anything like Tesla. Well, Tesla's just an engineer who lived in the last age, and I think he made something like that. I can't tell. I don't know what Tesla's engine was, but I think it's a similar thing. But he didn't know the reason where the power was coming. When Uncle Arthur made one, my Uncle Arthur made one back in 1950, he must have got the idea when he was in Germany, I don't know. But because there was a lot of publicity about this engine, and he must have seen them, I don't know, my mother saw them. And he must have, the family was split, between the anti-Nazis and the pro-Nazis. Anyway, so they were very vicious about each other, very angry. And of course my aunt's husband was killed, so she was bitter about everybody. That's what people get killed, they get angry. That's appears to be supporting the enemy. In fact, there's no reason why we shouldn't use the enemy's machines, because the enemies are all dead now. So go about it. And let's forget that and move on. But Tesla was responsible for this thing. He was a man to experiment with coils. That's what he did. He experimented, and he developed all sorts of things. Years before it was done by Hertz, he had radio before Hertz, and he didn't understand Hertz in a way, I don't think. He had his own ideas, which were based on a previous age, so we can't blame him for that because he's brought up in a previous age, and the Maxwell's equations hadn't been developed. I think he knew about them, but he had some other equations which were based on previous mathematics. And some of the things he said were based on what Maxwell said. Maxwell had longitudinal waves as well as Hertzian waves. And I don't think many people knew that. And I thought they were longitudinal waves first, but apparently not. It has to be explained to me that there has to be transverse. There has to be just to do the vectors. But it's really explained to me, and it took a long time to grasp that, because I thought they were longitudinal waves as well, because I brought up the past stage as well. And so a coil that is narrow like that is going to have more pressure in the middle. So you don't easily say, well, I get 20,000 turns like that. Probably not. But that's the idea. You've got to right it. It's got to be the right inductors and the right pressure, because the pressure is caused by the currents repelling each other. That's the important thing. And the current is carried by both the electrons and ions, so they can't get they move together. The electrons and the ions hold together, and that's the important thing. The plasma starts as a gas, normal gas, whereas everything's completely ionised. And out in space, it's the normal state of matter. So all sorts of things happen in space that don't happen here. And I call them transfusors. Actually, that was invented by a man called Steve, who lives in Birmingham. And he must be a tickled pink to think his name's being used, but it's a combination of transformer and fusor, which is an invention by another man, which is where the deuterium atoms are forced together by electrostatics, and well, it does work, but as far as there's no power. These things, well, they're not producing any power much yet, but they will do. And as I say, my Uncle Arthur produced one, and I do remember vaguely. It was a glass tube about that long, and it was round. There was a bung in one end. It might have even been a cork gun rather. I think it was rubber as cork, and he put an electrode in the top, and a big coil in the middle. I'm not sure how he wired it up. I can't remember, but it was quite low frequency, and there was a bottom one at the bottom. So that's the problem. So, and he rectified what he produced with a silicone rectifier, the old time silicone rectifier. It was a rectifier. It was a sort of plates with discs in. And they used to make them. They don't make them. The silicone rectifiers, different things now, but they look different, but sort of thing. And anyway, you don't know what to give it. It was the right voltage to run a small electric motor, which had an electric car I drove around. And I remember when I had to pump it down again. I did it with a styrofoam, a bicycle pump basically. And I was really young, so I must have been. They wondered if I was strong enough to pump it. But as I say, I was when it was terrible, they attacked him. Probably because they didn't know where the valves came from, so they thought I had a tame poltergeist in the tube. But that's only ice, basically. But I didn't know what it was, because I didn't know what it was. But later, after thinking about it, knowing about the hydrogen bomb, which about them, I thought it might be a nuclear fusion, but I didn't know enough about it to say. I didn't know anything about compression. I didn't know anything like that. I didn't know that coils compress things. I didn't know that. I really know. I just knew it was a coil of wire. I don't know how big or what it was. It was a very fat coil of wire like that. Very big, but it was narrow. I remember. It was in the middle somewhere. And when you start, a ball of fire formed in the middle, and that was important. And I've heard other people describe it, and often they probably die of radiation sickness actually, but they die. Because they get excited. Because it's often old men who do it because they've got the time. Young men have to get profit straight away, otherwise they go bankrupt. The older men, because I want to invest in income, I can play around a bit longer. And so that sort of thing it is. And the original one, I don't know. We don't know. I don't know what he did with the wire at the end of the car. I don't know. He may have wired it into the electrode at each end of the. And I think he started it with a motorcycle magneto. And the one when I made in the Alfred laboratory many years ago, and I don't know whether he used it or not, but that was similarly constructed with the wires coming out to the end of it. And but it used a copper tube. I think it was probably a quarter-inch copper tube, which was insulated. And there's a hole down the middle, which tubes have cold down the middle, don't they? They're sort of copper hole, called tubes. And it had liquidation going through the for this gas liquid, so it cooled it. And it was, I think it was not that many. I don't think it was that many inductors. It wasn't huge. It wasn't hundreds and hundreds. It was reasonable in this. But it used itself. I did put a capacitor in, but that was quite small. I was told that didn't do anything because it was the self-capacitance of the coil. And of course, I wasn't convinced to see inside the coil, so I may have been a capacitor. I don't know. I doubt it. But it was running at low frequency. Now you can make coils run at low frequency with big capacitors, and because it's running at a lower frequency, the rate of change is smaller, so the voltage is smaller. So, which the voltage, the voltage I've got on this one is huge. It's okay, it's actually probably about 40,000 volts, which is a bit too much, and that's about right for a Tesla car, which is basically the idea is to ionize the gas. And as I say, I've measured through the gas. I can measure that's going along the tube. There's 100 milliamps, which is reasonable for gas current. But the circulating current, because you've got this 80,000 term car with estimated 40 milliamps, it's calculation 40 milliamps. I haven't measured it, but I can't measure it easily. It's quite dangerous to use a calculator because it's high voltages. I could measure it somewhere else. But measure it, it's where I measure it. But that's in series with the pipe going through the side, so it's probably, well, the actual current varies from that, but it's probably about 40 milliamps, 100 milliamps. It doesn't matter. And so if it was 100 milliamps, you've got 80,000 turns. The ampere turns is 80,000. So I do it in a calculator, but if I get it right, it's 80,000 times 40e minus 3 is actually 3,200 ampere turns. That means the plasma current is 3,200 amps, and that's if it. But I think in order to get that, I need an oscillator. I need a 400 amp oscillator. Now I can't make one of those. It can be done. I think the man I know in the Netherlands has got a transistor, which is a MOSFET, which is got a big thing that takes 1,000 amps, so that would do it. And you can make an oscillator very simply by having a. Well, the trouble is you put coils, so you pick up the coils, they pick up the voltage. And the one I'll put an extra winding on it, and that is sitting at 40,000 volts. You know, and can't use that. So to get the feedback, I've got to try to do it because we do very high voltages, and it blows up the computer. You know where it comes from. There's sparks, or there might be sparks, and it's very dangerous. You get a shock. It's very low. Well, 100 amps is quite large current. You know, if it goes through your body, you've had it basically. So I do get a shock, and it's dangerous. So it's a dangerous thing. So put the yes. So that's 3,000 amps. So the plasma current is 3,000 amps. The tube is slightly bigger, so the current density is reasonable. But the current density is right. The current density is important thing to concentrate the energy. And the actual fusion energy is very small. And the power is, well, I'm using hydrogen, the power is very low. Air, I don't know what the power is because I don't know what the reaction is or anything about it. Idea. You could look up some idea, but you wouldn't know by just looking at it. Calculation, you have to measure it. But with deuterium, the reaction is quite powerful, and that's what they use. First, ITER, you know, they use deuterium, and but it's very dilute deuterium, it's not very low pressure. As I say, it's really about 5. So that's the secret. I wouldn't tell you that. 5 torques, like that, first 10 torques. And they get into people plasma in it, so that has to be quite low pressure. And with my idea, it's using a mixture of hydrogen and deuterium, which will, as it burns through the hydrogen, will react with the deuterium reaction produces neutrons, which react hydrogen to produce more deuterium, so you don't need to keep on doing it. So it's not a breeder, but it is just can be used like that. So the neutron flux is therefore stopped in the tube by the hydrogen. So the only thing becomes dangerous towards the end when it runs out of hydrogen, it then starts doing other things. The one I used at the RSRS, I've been told by others had air in it, and the reaction produced carbon. You've got a layer of carbon, so it's very dangerous. It was a supernova in a tube. But that one, there's more than one. One of them was started with a massive valve. I think it was 2,000 volts, which is not huge, and it was taking about an amp, it took about an amp, so it was actually quite a lot of power. I don't think I used it at full power. I had a massive flute power supply, and that ignited it. And you couldn't turn it off. I remember it was, and I was told later I was already using part of the cars because I used a Taurus, and Taurus is no good, not racy. And so it was a valve where the whole thing was done electronically, so the controller doesn't touch it. So I was not given permission to do the whole thing. So all I did was wire it up, and basically that was that. And the next one, as I say, was this coil of thick wire, which was a copper tube with an insulation on it. And that was interesting it was, because I think the voltage, I think the output was only about 2,000 volts. It wasn't huge, and so the voltage wasn't huge. I can't remember. And this it was several hundred amps through this copper pipe, and that was started by a car battery. I remember a car battery was connected to it, and it was the interrupter. So the interrupter produced the high voltage, which then started the action. It was simple as that. Just push button start. Just push the button, started it. I'm trying to do this here. Now, if I was to do the whole thing here, and I think I could use this heavy wire, this wire. Oh, this what's it called? It's jump starter cable, which you can buy quite long lengths. It's quite expensive, but you could do. And I can make a coil, which would be quite fat, and that could be, and that's another possibility. And have the jump starter and start that. But then the interruption would just swap, but it would be a similar current sheet, but it'd be a different configuration and a different frequency, and that might be better. So there's the actual. You can use a heavy coil, a big coil, because you can use thin wire and a light current, thick wire, a wire, a coil on a plane, or you can. And so there are a couple of other combinations involved, and they all work basically. The important thing is to get the right fuel, and you see, I think the one I had was there was a gap in it. There was the coil, which was copper, which was a massive thing. I had a huge amount of it. You have to use a forklift truck to get on the table, and it was about 50 centimetres long by 50 centimetres in diameter. And the coil didn't go to the centre. It was a big space in the middle, and that was filled in with some, and it had a silicon tube through the middle, which was like they're called quartz these days, quartz glass tube through the middle, and that was connected to a vacuum system. And deuterium was fed in at one end, so a pressure relief valve, and also a needle valve, and there was a vacuum pump at the other end, and the vacuum was actually quite sophisticated, and that was taking power separately, and I was able to run a 1/4 horsepower motor on it. But that was oscillating at quite a low frequency. I think I don't know what the inductance was, but certainly, I mean, these 100 hertz, 100 Henry, 100 hertz, 100 Henry. I can't believe it. It would frequency, such a high frequency of 700 hertz. So that's a calculation. That's what the measurement said. And I would have thought I could calculate it. 100, because those are capacitor would go down. I have got some capacitors and I might put them in. That's a possibility, but I won't do that yet. That'll bring the frequency down. And that will increase the current because it's going to be so it's entirely different kettle of fish. So I might do that. So that's a possibility. That's the next stage. And I think they were provided by a Chinese company who did them. He helped my project. And I probably used them. I've still got them, and they're still in packing. And the design called for 4 of those. And that should bring the frequency down. So I may well put it in. That's the next stage. Now, I don't like this high voltage. I'm really quite frightened of it. But the current is very strong, but it is dangerous. With the capacitors, that'll bring the frequency down. And it shunts on the current. It's because then the current through the pipe becomes in parallel with the capacitor. So it's a tuned circuit with this, and that might work differently. So that'll be the next step. And bringing frequency down might start up. So I've got to experiment to be sure. The first, I think the one that had a double capacitor in it, external, and it was a small capacitance. It was a small capacitance of about 2,000 picofarad or so, about that. That's what, but it was an oil-filled thing. I watched it 2,000 watts. So that's why I remember it was 2,000 watts. And yeah, so that was what it was, a fairly amateur thing. And I think they were interested in my construction skills. Of course, in the sort of service, if you do that sort of work, they chop your head out, so chop your brain out, so you stop producing things. And so I think the doctors did it. But, yeah, they lost a genius and found an idiot. So I didn't ask them. And doctors think once you got a job and a girlfriend, you don't need a brain. But it's nonsense. It depends on your job, but it's Dark's idea. The idea is you can do it without brains insane. Doctors do it hand, basically. And well, I've recovered several times from brain damage, and it's not a good idea because it disables you. And if it's very bad, you're unconscious. So doctors who do it should be publicly excused. And I think beheading them is probably the best thing to do. They're mad and insane to do that. And it's been used for a long time. I understand these murders have been, these brain damaging murders have been done for about 6,000 years and produced robots or slaves, and well, it's atrocity, and you've been murdering people for 600 years. It's probably obvious that the people involved that they're murdering people, but they are, and it should stop. They're very angry, and they the worse they do it, but certainly it's not a good idea. The psychiatrists set up to murder people, and it's all wrong. I think they think they're producing workers, but they're no good, and that's what a lot of the entrepreneurs who employ these brain damaged people, they can't do anything. They're useless. And apparently, even Margaret, my cousin, a psychopath killer called Margaret, who's stolen my money, she is my cousin. She's not alive for years, but I've not replied. She's not replied to me. But she's done that. She was a senior civil servant and in charge manager, and I think got a position in the civil service. And she had people in drawing offices done like that, so they make good draftsmen, but they don't understand what they're doing. So that's an atrocity. That's what Britain does. An atrocious place. Britain because it's atrocities in this country. It's terrible. Been going on for a long time, but and they say 6,000 years, well maybe, but it's just atrocity. That's what it is. And they're killing people, and I feel very angry. It's Christians who do it at the moment, but before that, somebody else. And I feel like tearing people apart because they're Christians, psychopaths, that's all they are. Chop your brain out. They're insane. They're killing people. And so the people who are less alive, unconscious or partly conscious or disabled, it really is appalling. And but that's probably what they hit the war was about, and really atrocious. Anyway, so it's atrocious. Hopefully it'll stop. put the trigger on the other side. That's how it goes. Very sorry. That worked that time. And there's the emboss. I've got a trace. I've got a trace. Double trace is the neutron detector. That's on 10 milliseconds. The frequency of the frequency that that's the transfusor. That's right, using around like that. So there's the trace, and presumably that's the oscillation. You can see the oscillations on the other trace as well. So there's the trace. So there's a trace on both of them at the same time. There's the pulses, essentially 10 milliseconds. So there's the trace. That doesn't make much sense. It's a wavy line. I was expecting a series of spikes. So that could be a series of explosions which have kicked the thing up. It could just be interference, of course, couldn't it? I don't know. It's not doing what I expected to do, and I can't do a tracing because it blows up the computer. I lost the picture at one stage, and then the mouse stopped working. And then I've lost one of the ports on the hub, so it's not actually working at all. So it's a very bad idea. The high voltage computers don't go together.